There are a few other NSM data types of interest to the network security analyst. In this section, we'll discuss extracted content, statistical data, and metadata. Let's focus on each of these, and we'll start with extracted content. NSM extracted content includes artifacts that are carved out of real-time streams or out of PCAP files. The first artifact that springs to mind is usually files, but the artifacts may be larger constructs such as full web pages. The artifacts may also be smaller pieces of data, such as particular strings defined by an analyst query. Bro is capable of extracting files from the streams that it analyzes. In Security Onion, the default Bro configuration will extract all Windows executable files that it recognizes. Bro can be configured to extract files of other types as well by modifying a script. Security Onion also includes the free edition of Network Miner, which can be used to process PCAP files and extracts several types of content. For example, it extracts all files, including certificates that are exchanged during SSL/TLS negotiations. Image files such as PNGs and JPEGs are organized separately from other extracted files. It also extracts several other artifacts that may be interesting to the analyst. Some of the artifacts may include session data, which is all about network connections, including the standard IP 5-tuple. It can also extract DNS transaction data documenting all DNS requests and replies, and also host, which lists all the IP addresses seen in the PCAP along with other relevant information that can be gleaned from the PCAP. Potential information includes DNS host names, OpenTCP ports, operating systems, sessions associated with the host, and total packet and byte counts associated with the host. Now let's move on to statistical data. Session data and transaction data both document individual events. Statistical data aggregates the individual events and provides summaries of the data. The analyst can use the summaries to develop a clear and coherent picture that may not be discernible from examining individual events. Statistical data can be queried and reported in different methods. What is included in the report is based on the analyst query. The analyst query is directed by the analytic process, and as an analysis is performed, the analyst will form a picture defining what they know and what they don't know. At any point in this process, some aspects of what they don't know are going to become more interesting than others. Relevant queries against statistical data can answer certain questions. Two common questions that come to mind are top reports and baseline graphs. Top reports can answer questions such as, which host requests the most HTTP data? Which hosts serve the most HTTP data? And which DNS domains are the most requested? Using Security Onion, the session and transaction data that are collected by Bro can be queried using ELSA. This allows you to produce top reports, and in this example, displayed are the top HTTP servers based on transaction counts. Baseline graphs provide a visual representation of quantities over time. Statistical data, which are collected over time, produces those baselines. The baselines define what is normal, and normal is rarely constant. That means patterns will vary by time of day and the day of the week. This graph represents a 48-hour window taken by Cisco StealthWatch. The daily patterns are clearly visible in the graph. Baseline analysis is commonly used for anomaly detection. The baseline defines what is normal, and deviations from normal are anomalies. Anomalies are interesting to the analyst. Some anomalies turn out to have benign causes, but many turn out to be caused by the activities of threat actors. Just be aware of longer term cycles though. Since this graph shows just 2 days, it is not representative of activities that occur outside the window, such as backups and security scans. Lastly, we get to metadata, and metadata is data about data. Metadata can be gathered about any artifact that is collected with NSM data. A very simple example are well-known TCP ports. Generally, the TCP port is the data that is directly connected in the NSM process. Some applications can perform protocol decodes and recognize the network application regardless of the ports that are used, which can also be considered metadata. Many NSM tools will augment IP addresses with metadata. Examples include geolocation, and this is the geographic location including country and potentially accurate down to the city. Ownership is where an organization that owns the network to which the IP address belongs. And in reputation we have such things as email. And one question you can ask here, is this the IP address known for delivering spam or phishing campaigns? And for command and control, you might ask the question, is this the IP address that is a known botnet control or other remote control access threats? And we have malware, and you might ask the question here, is this the IP address known for delivering malware?